Hello, in this video I will show how to perform 3+2 indexed machining in SprutCAM. Well, we would like to machine this part and go to machining, and we can see that the part inside the table. So the first step, I would like to locate the part, to put the part onto the table. The best way to do it is to create new coordinate system. So I would like to create coordinate system on this plane. I select it, and after that I place the part near the desired origin position and click create coordinate system. So the new local coordinate system has been created, and this is x-axis, y-axis, near the place x-axis, y-axis. Well, make the machine visible and set workpiece setup, local coordinate system 1. Okay, add the additional movement, for example 20 millimeters from the table. Okay, well, the next, I would like to locate the right origin position, G54. To do it, I have to select workpiece coordinate system, click this one, take this one and put it in any place I want. If I want to attach this position to this corner, for example, I have to enable this smart snap feature, and then it can be added. Well, I can make the workpiece visible also and attach it to the workpiece. Okay, put it in this position. This is the coordinates of workpiece coordinate system in the global coordinates system. Okay, well, so the first machining I would like to perform is machining of the top face. To do it, I create roughing plane operation and add this face as bottom level. Calculate the toolpath. Well, very good. Let's look onto toolpath. We can see in the header this coordinate system G54. This one, G54, it has coordinates minus 35 x, 35 y, and 158 z. This is the distance from the rotary axis intersection point on the machine, so we can use it. Well, the next step, for example, I would like to machine this side. To do it, I also create roughing plane operation and go to this one. So the first step, I would like to calculate the right axis position to machine this face. To do it, I select this rotary axis, click on this face, and it calculates the real position of A and B axis to achieve this place. Okay, well, calculate the toolpath. Oh, I have to define the bottom level. Delete this face and add this face as bottom level. Okay, calculate. Very good. Maybe set one layer. Okay, well, let's look on simulation. We have G54 here. The coordinates distance from zero position is known. I simulated well the first operation. After that, go to the next operation. G54 stay on the same place. Go in this way and simulate the second side. Well, at the current moment we have the same tool for both operations, and for example, I would like to go up to the maximum before rotation. How to do it? For the first operation, we don't have return right now, but I can edit manually. Well, to do it, I have to set roughing plane and define return reference points, physics machine coordinates, Z0 at. Okay, we have this one in origin. If I recalculate this one, then in return we will have this physics go to Z0. By this command you have to generate in the post-processor G28 Z0. Well, calculating the next operation. So right now we have this motion. It goes up and goes up, and after that going to the next rotation for the next operation. Well, so if I want to locate the new coordinate system for the inclined workpiece, how to do it? Click workpiece coordinate system, click this and attach it, for example, in this position, and define another workpiece number. Okay, so it is located right now. You have to define this rotary axis position before. So we set axis position for our operation, and after that we define this position. Okay, calculating toolpath. So right now for the second operation, we have G55 here, rotation AB, it put in these coordinates, and toolpath is calculated in this coordinate system. Well, it seems that enough for a moment. Thank you for your attention.